Layer 4, or the transport layer, ensures end-to-end communication, reliability, and flow control. This layer performs message segmentation, where it accepts a message from the higher layers in the OSI model, in other words from the session layer above it, splits the message into smaller units if they're not small enough already, and then passes the smaller units down to the network layer for sending. The transport layer at the receiver will reassemble the message at this layer. This layer also handles transportation issues between hosts and ensures data transport reliability. The two main protocols at this layer are TCP, or Transmission Control Protocol, and UDP, or User Datagram Protocol. TCP provides reliability. It establishes, maintains, and terminates virtual circuits between devices. So two end systems will go through what's called the TCP three-way handshake to establish a connection between each other. Packets are sequenced, and if packets go missing, those packets will be retransmitted. Please refer to the TCP and UDP video for much more detail on the processes used by TCP and UDP. UDP, on the other hand, does not provide reliability. If packets are dropped, they are lost, and higher layer protocols at the application layer would need to ensure reliability. So UDP doesn't retransmit lost packets. TCP would, however. Flow control may also be implemented at the transport layer. Flow control will manage data transmission between devices to ensure that the transmitting device does not send more data than the receiving device can process. As an example, you could have an iPhone receiving traffic from a powerful server. The server has much more CPU processing power and perhaps a very high-speed interface. The server could send so much traffic that the iPhone is overwhelmed. So the receiving device, in this example the iPhone, can tell the transmitting device, in other words the server, to back off or slow down when no message buffers are available. Session multiplexing also takes place at this layer. This allows for the multiplexing of several message streams or sessions into one logical link, and this layer will keep track of which message belongs to which session. UDP, on the other hand, does not give us that kind of reliability. UDP is normally used for applications such as voice over IP or VoIP, which does not require retransmission of packets. In some cases, such as with VoIP or voice over IP, retransmitting packets would be irrelevant, and thus applications would use UDP when retransmission is not required. UDP is also more lightweight and has less overhead than TCP. UDP does not use sequencing or provide other reliability mechanisms that you get in TCP. One of the well-known analogies to differentiate between TCP and UDP is to think of TCP as a telephone call. When I phone you, I get an acknowledgement from you that it's you speaking, because you would typically say, "Hello, it's David speaking." So you're going to at least say hello and then probably mention your name. If I give you a piece of information over the telephone, such as a string of numbers, you may repeat that back to me to ensure that you got the information correctly. So as an example, if I told you that someone's telephone number is 555-1212, you would repeat that back to me. You would say, the number is 555-1212, and that ensures that both of us know that you got the information correctly. That's a very similar mechanism to TCP, where all information that is transmitted is acknowledged. So there's an acknowledgement of receipt of information. If the information is not received properly, it's retransmitted. The analogy for UDP is that it's like a postal service. If I want to give you someone's telephone number, I write it on a piece of paper, put it in an envelope, and then I mail it to you. But in this case, there's no guarantee that the piece of mail will actually reach you, and in the same way, there's no reliability in UDP.